with your mentor Abhilash Sarkar. Now, in this episode, we'll see some of the left out expressions that I have explained during my previous episodes, where things are being kept in hold due to some of the things we are not knowing at that time, but later we have learned. So that one of the things that is needed is the multiplication of two matrix. So now we have learned how to do multiplication of two matrix. Then we need to have those things to be proved that I have explained just as a property of any matrix. So one of that it was regarding the transpose. What I have told that if two matrices are there, if I take the transpose of that, that is equivalent to the transpose of the first in order multiplied by the transpose of the second in order. So second in order, and then after the transpose of the first in order. So that means if I have to get A cross B whole transpose, then that will be equal to taking in order the second first of the transpose. If I do the transpose of that, then at the same time I will calculate the transpose of A, and then if I do the multiplication, I will get the same result what I will get here and here. That has to be proved. Now, as I know how to do the multiplication, then it will be easier. So for that, I will take a smaller matrix, and this matrix will take of the two different order. Let's say A is taken as A11, A12, only two elements on the other side. This is 21 and 22. Let me confine it. So it will be very easy to show the computation. And B I am taking, for example, and this time I am taking generalized. This could be taken as a numerical value also. This will give you some faster result. Okay, but anyhow, this I am taking B11, B12, B21, B22. Okay, these are the two matrices I have taken. So we'll see the operation on these two matrices. Now we'll go with the left hand side first. Let us see where we land up. So first here I have to do A cross B. So what I have to do, A cross B. So that means if I see, I am just straightforward writing because we know how to do multiplication. So what you have to do, A cross B, that means the order is 2 cross 2, there also 2 cross 2, so there is no harm in, so I will get 2 cross 2 definitely. Okay, because the extreme is also 2. So what would be the result? This multiplied with this, so term will be A11 into B11, then plus A12 into B21, sorry. Okay, so what I will get, I will get this into this plus this into this, isn't it? Row, column. Second term, let me expand it a bit because I need some space. The second term of here is this row will be same, column will change. So A11 B12 plus A12 B22. Third, there this into this, A21 B11 and then A22 plus and B21. This will be and the last one will be this row, this column. So A21 B12 plus A22 B22. So this will be the ultimate. This is 2 cross 2. I need not to write, but still I am writing. Okay. This will be the result where I will get left hand side after multiplying A cross B, because I am just doing multiplication of A cross B. Now I have to take the transpose. This is the result where I got this A cross B. Now what will be the transpose value? The transpose is that where row will convert into column. simple as that. So what will convert that? This will come along vertical. So this will be 1 1 position. This will not change. 1 2 B2 1, and this will come here. P1 2 plus A1 2 B2 2, and this will go there, and A21 B11 plus A22 plus B21, and this term will be remain here, as because it is 2 cos 2, so not much will change, but as per the rule this was A, the last one, this 2 1 1 2 2 2, this is 2 2 B 2 2. Okay, fine. So this will be my ultimate result of left hand side. Okay, remember this. Now I will work on the right hand side part. So for right hand side I have to calculate separately first B transpose. So B transpose will become transpose of this. This will turn, this term will come here. 1 2. This will go there, B21 and B22. This will be the B transpose, and A transpose will be A11, A12, A21 here, A22 will be there. Now I will rub the original one. This is not needed. Actually I need some space here so that I can see the computation of this. So when we have two transpose, now my task to find right hand side, that is equal to B transpose B transpose cross A transpose. Okay, this B transpose. So now we have to multiply. You know the multiplication. Now what is that? This by this. So I am just writing the term B11 A11 plus B21 A12. Okay, now next is this into this, B11 A21 plus B21 A22. Fine. Now this term, this into this, B12 A11 plus B22 A12, and this equal to this into this, that means B12 A21 plus B22 and A22. Now let me match the term. A11 B11, okay, A21 A12 B21, so this is matching, right? Second, A21 B11 A22 B21, this is also matching. Next come here, A11 B12 A12 B22, this is also matching. The next and the last almost to match, A21 21 B12 A22 B22. Now see the result, this is matching. So we can, hence we can say A plus B whole transpose is equal to B transpose cross A transpose. This has been proved. So this I have kept hold as because multiplication was not being taught. So that is proved. This is the one of the rule of the transpose. So this you have to remember. Okay. Other one that time on the transpose I have already proved. The transpose, when it is done twice consecutively, will got back the original matrix. So that was there. Next is your finding determinant. So determinant, and you know the determinant is being signed by a mod sign with two parallel line in between. If you put the matrix, so this will denote that we are computing the determinant of matrix A. Now this can be done with the two process. One is with the help of cofactor. I already have discussed how to find the cofactor of the matrix. So with that cofactor we'll find, or second one is direct method. So there are two methods that I will explain how to get the two methods are there how to get the determinant. So let me assume a matrix to be discussed of a very simpler form I am taking so that you can understand it better. So one is A is equal to 1 2 3 3 2 1 or 2 1 3. So this way. So now if I want to calculate the cofactor, let's say C is the cofactor of this. So what would be the cofactor? So where we'll build a matrix with the minus of the elements. So that will be the cofactor. So first of this will come this way, this and this. So 2 into 3 and minus 1 and 6 minus 1 and the position is plus. So plus 5. The next one is this one, this row, this row, this column. 3 into 3 9 minus 2 minus 7. The position is minus, so minus 7. Then this one and this one. 3 into 1 3 minus 4 minus 1. Position is plus, minus 1 will be there. Next come this. So this and this will go. 3 to the 6 minus 3. 3 position is minus, minus 3. Next come this and this will go. 3 into 1 3 minus 6 minus 3 position plus, minus 3 will go. This and this will go. So that means 1 into 1 1 minus 4, that is equal to minus 3, position is minus, that will become plus 3, isn't it? The last one is this and this. So this is 2 minus 6, that means minus 4, position is plus, minus 4. The next one is this and this. So 1 into 1 1 minus 9 minus 8, position is minus, so plus 8. And the last one is this and this. So this will be 2 minus 6, so that means equal to minus 4, position is plus, minus 4. Okay, now once I get the matrix with the cofactors, my determinant will be is defined as, the determinant will be when we'll get summation of all the elements of matrix A, when we multiply with the relative cofactor of this, when only either I varies from 1 to n, if it is a order of 1 to n, this is generalized form I am writing, or j varies from 1 to n. So that means I mean to say, if you are calculating with rows, so these rows of the elements and these rows of the elements will be multiplied and summed up. So there I will get this determinant that you can do with any of the row. So the respective row elements you have to multiply and summed up. There, if I take the second row, so that has to multiply the second row elements and the respective position has to be multiplied. So that means if I take this row and this row, the first element will be multiplied the first element plus second element will be multiplied the second element and so on. So or else you can do the multiplication of the column to column, and that case also the respective position will be multiplied and summed up. So let me check what is the result. So first of the kind, if I multiply the rows, first row to the first row, so this is 5, okay, this is minus 14, this is minus 3. So I am getting how much? 17 minus 5, that is equal to minus 12. Okay, let me check other one. Determinant taking first row, okay, and all three columns, okay, all three columns. Second row, all three columns, let's say. So this is not the right way of denomination, just for understanding and writing. So don't write it, just keep it in mind when I am doing with the second row. So then 3 into 3 minus 9, 2 into 3 minus 6, 1 into 3 plus 3. So how much I am getting? Again 15 minus 2, that is equal to 12. Okay, let me check. So this will go like that. All three, let me check. Okay, so this will be clarifying your doubts then if it is anywhere. So 2 into 4 minus 8, 1 into plus 8, 3 into minus 4, 12. So this is straightforward minus 2. So all the rows we have checked. Now we'll check with the columns. Okay, let me check with the columns. So this also then for formula can be written as j varies. So here I am just varying I. You can vary j1 to n, where a ij, and the same thing has to be multiplied with column that elements of. So here if you vary j, so you will get this number where I will fix. Here j is fixed. Okay, j is fixed, here I is fixed. Accordingly you can understand. So if I say this one, so let me check with the columns. So this column to this column. So the first one is 5, 3 into minus 3 minus 9, 2 into minus 4 minus 8. So that is equal to 4, 9 and 8 is equal to 17 minus, so this is 12. Let me check the second row. This and this is equal to minus 14, 2 and 3 minus 6, 2 and 4 plus 10. So how much it is? This is 20 minus 12, this is minus 8 is equal to 12. So last one, let me check. This one, 3 into 1 minus 3, this is plus 3, and this is 12. So this also is minus 2. So you can check. So any of this thing will give you the same result. So to find the cofactor, you can see the results are coming soon. So here one thing, to reduce the effort, you need not to calculate all the rows and columns. Instead of that, only if you once you know that it will give you the same result, only if one row or one column if you calculate, it will give you the same result. So you need not to calculate all the cofactors. Okay, so if you find this one, so further you can reduce your time. Okay, so this is one way of doing that. Other way of getting determinant, if I take the same example, then you can clear or clarify your if in case any doubt is there. So I will take the same example 1 2 3 for the second method. I am saying 3 2 1 and 2 1 3. Here only thing is that you have expand the matrix. So you know how to expand the matrix, and you will get your determinant. So determinant of that when you expand the matrix. So how to expand the matrix? Element into your this one, 2 into 3, 6 minus 1, that is equal to 5. Alternate plus minus, this plus, this is minus. So then second element 2, then equal to 3 into 3, 9 minus 2, 7 plus the third element 3 into 1, 3 minus 4, that is equal to minus 1. So here 5 minus, so that is equal to minus 2. So you can see the result becomes minus 12. So this is a very straightforward method, and you need not to calculate the cofactors. You are getting it. But whereas both the methods should be known to you, because in case it has given to go with the cofactors or do with the cofactors, then there will be a difficulty for you. So better to know all the things, but whatever you find easier, you will adopt that. There is no issue. And another method that comes under this direct method is the method when let's say this matrix again, I'm writing the same one, 1 2 3 3 2 1 and 2 1 3. So this, what I will do, I will put it in a repeated manner. I will write it repeatedly once after another, means side by side, and I will assign a predetermined sign on the top of that. So this first three columns is a plus, last three column will with a minus. So then with a significant way of multiplication, so I will multiply the digits that is cut by these diagonals, okay, and I will sum up. So the slant line coming from top to bottom, with this way it will be added first, and then I have to deduct it from this other way of cutting the digits. So let me count 1 into 2 into 3, that is equal to 6, plus the second is 2 into 1 into 2, that is equal to 4, plus 3 into 3 into 1, that is equal to 9. So all over minus the other way, 1 into 1 into 1 1, minus 2 into 3 into 3, that means 3 is a 9, 2 is a 18, okay, then minus 3 into 2 into 2, that means equal to 12. So let me calculate. This is 10 plus 9, 19, minus 18 plus 12 is equal to 30, minus plus 1, 31. If you calculate, I will get 12. So this is another way of doing calculating the matrix by direct method. Okay. So this way you can find the determinant. In the I will end up here. In the next chapter, I will show you how to find that I kept hold during discussion of the topic, where I said that matrix into the inverse of the matrix will give you the identity matrix. This was the rule. So but in that you have to find the inverse of a matrix. So how do you have to find that, I will discuss in the next chapter. So thank you for now.